when you are interested in vintage electronics and old computer monitors, this is perhaps an idea. It is a monitor of 1987 or 1984. I don't know that exactly when I bought it, and it is the Commodore PC1. I found on the World Wide Web completely new monitor in the box, but I repaired it, this original computer monitor, that's what I mean. So the computer monitor is here, the PC1 is started. It does not start very easily. There are some tricks to start it, say especially when you put the floppy drive in and then switch the computer on, and then it sometimes wants to start, and well, anyway, in my idea it's very good that after such a long time such a floppy drive made by Commodore in those days still works. That's one important thing that I wanted to tell. Anyway, here is the schematic of the monitor. I repaired it, or I did not repair it. That's perhaps very strange to say. There are two here, and they are not visible here, two potentiometers with which you can set the brightness, and here again a kind of brightness. And perhaps these potentiometers were not in the right position when I tested the whole thing at first, but anyway, that are, say, all the more or less common things and hobby things that you can encounter when you have such a very old computer. Want to tell something more about it? This is the original Commodore keyboard. I once connected in the very past a not original Commodore keyboard, and I forced it a little bit into the plug and the computer was damaged. I did not repair it by myself, but anyway, it had to be repaired. And when you are a little bit interested in old school electronics, here you see, say, the standard parallel port and the standard serial port, and here info about the Commodore computer PC1 that I bought in the 1980s. On, off, and here is the plug that goes to the monitor. It is not a graphics monitor, but via an emulation program you could get it into a certain graphics mode. Anyway, I repaired it. It was quite a problem to get all the, say, the potentiometers that are responsible for the vertical size, vertical hold, vertical linearity, etc., etc., to get them properly back into their position. But anyway, the keyboard is connected here via kind of DIN plug. So let's go to the schematic of the monitor. This is again that monitor. Perhaps I had to, say, align here these two small potentiometers that are responsible for the brightness and for the sharpness, etc., etc. But it could also be that the monitor was really defective, and here is the schematic. I tested and tried, etc., etc. I worked 1 day on it, and perhaps this was the reason. This capacitor here, it is 2.2 microfarad at 160 volts, was not okay. I replaced it, and after that the monitor worked again. I had to do, say, quite a big research. The first idea is always, when we are talking about a high frequency generator, and that's here, this is the high frequency generator that supports the high voltage for the tube here. And these are perhaps high voltage diodes, etc., etc. Anyway, the first idea is always to check the high voltage transistor, and it was a BU806, and it is driven here by 2 other transistors. I checked all the components inside the high frequency, the high voltage unit. The transistors, I soldered them out, this one. I tested them on the transistor tester, and the problem with a high voltage transistor here, like here, is always that it needs a high voltage when you want to test it. So when you connect that to a standard transistor tester, you see nothing. Say no amplification, etc., etc. But anyway, that gives always, say, kind of doubts. Is it okay, the high voltage transistor, or is it not okay? And in general, a high voltage transistor has a very low current amplification, and then I'm talking especially about high voltage transistors of the 1970s, early 1980s, etc. So, well, what's more to tell? My idea was that at first, of course, all the voltages had to be okay. So I saw here in the schematic that the voltage in general was 12 volts. Only here in this part of the circuit we see a voltage of 400 volts. That's very, very high. And in such a case you can also think, well, is that still there? You can measure it. It could be that the diode is not okay, etc., etc. I've measured all the diodes here, and they were all okay. Measuring a high voltage diode is always a problem, because it cannot be measured with a normal ohms meter. You need an ohms meter that can measure very, very high resistances, and that's, say, more or less standard. When we are talking about old school high voltage diodes, there were often, say, 100 or so selenium cells, rectifier materials. They were in a kind of tube, ceramic tube, and all these elements could together in series rectify the high voltage. That's not, of course, the case here. We have to do with a modern circuit, etc., etc. Well, what did I test more? Of course, I tested the power supply. That's in fact very easy to test and measure whether the voltages are present. and this was also a kind of ID. There is here a TBA 117N, and when you look closely to the circuit, this chip here is able to drive the horizontal and the vertical coil. So you can see it here, vertical V, horizontal, etc., etc. And these coils are of course on the neck of the tube. I measured the coils, they were okay, so you can measure these coils very easily with an ohms meter. Then you can see whether they are okay, and they are connected also, say, to the driver of the high frequency circuit, and that's in a certain way of course normal when we look at old school analog cathode ray tube television circuits. There's, say, a combination of a 16 kilohertz line transformer, and that 16 kilohertz line transformer is driven via a certain signal. Anyway, I tested this chip, try to find the output. I did not use my scope. I don't want to use my scope on, say, high voltage circuits, because they can get broke when the input of my scope is connected to a high voltage circuit. In this, say, monitor, I'm always very afraid that it gets broke. And I don't want to spoil my two oscilloscopes, and especially not the digital oscilloscope that I bought via Ali a few years ago. Anyway, I'm on 12 minutes on my camera, but anyway, this is a driver for the horizontal, for the vertical coil, vertical deflection coil, and this is the, as far as I could see, the horizontal deflection coil. My camera starts to flicker, I have to stop. Anyway, thanks for watching. I hope it was a little bit interesting. I can elaborate more if possible. Say, standard power supply here, more or less standard power supply. I tested, of course, at first all the voltages, the supply voltages, and I did not test the high voltage, especially because that's difficult. It is here a high voltage on, say, approximately 16 kilohertz. It's rectified here by the diodes, and then that static voltage goes to the tube. That's now not visible here. But anyway, well, measuring high voltages is a kind of other issue. Perhaps I will tell more about it in the future, but anyway, let's look again to the schematic. Here the driver of the vertical coil. Here the high frequency part of that circuit, and the driver of the horizontal coil, and here the power supply, etc., etc. And well, it was completely not clear to me, even up to now, how this circuit worked. I have to say that. Where is that line frequency generated? Could be, of course, that we have only here a driver, and I cannot compare this to the classical old school analog television set, but anyway, there's here a driver, and that driver is connected to the input, and that are the horizontal and the vertical input pins. I cannot show it at the moment because I have to skip here to that side, and in that case I could be that I lose, say, the schematic. Anyway, here that beautiful green light of that computer, Commodore PC1 monitor. It's a little bit wobbling here, and my idea is that it could have to do with electrolytic capacitors. Well, let's see. Anyway, I hope it was a little bit interesting. Thanks for watching, especially for everyone interested in vintage computers.